Good afternoon. My name is Junho Wang. This presentation will be on the focusing profiles of planar silicon dioxide, metamaterial gigahertz frequency ultrasonic lens. The outline will be on the introduction, the ultrasonic lens design, lens fabrication process, bonding and alignment, and finally the experimental results. The idea of using the ultrasonic for Fourier transform is to implement a device where ultrasonic is transmitted through the lens and focused as the focal length and forming the Fourier transform at the receiver. The complexity of 2D fast Fourier transform using a conventional device is n squared log n, whereas the complexity for this device would be n for a fixed n. We also implemented a C++ simulation shown on the right-hand side, where a pie-shaped transducer is converted into a Fourier transform after passing through the first lens and is formed the inverted original image after passing through the second lens. There are different lens designs, including the convex and concave lens, is shown on the PowerPoint. And there's another type of device called Fresnel lens, where there are different step height for different materials. But we chose another method to make a CMOS compatible thin lens, which consists of spatially varying density of silicon dioxide inside a silicon wafer that acts as a metamaterial for different index of refraction. Another important character is the diffraction efficiency. And in order to achieve a diffraction efficiency over 90%, we need to make a 7-step lens. This is a fabrication process where a silicon wafer is etched using DRIE after lithography. We strip the photoresist and grow oxide inside the trenches using the furnace, and finally do the CMP. The picture shows that there are no air gap where the oxide is grown inside the silicon holes. This is the alignment and bonding. We use the PicoMA fine placer to bond the lens and the transducer, and we verify it using a microscope. This is the experimental result. We observed a focusing effect at 676 megahertz and also at 1 gigahertz. The thickness for this device with or without the lens are the same. And this device was initially designed for 1.2 gigahertz. I'd like to thank you for joining this presentation, and also like to thank Filterra IME and the funding agency. Thank you very much.